Hello, and then welcome back once again. Just like we started yesterday and then the day before yesterday, we want to continue with elective mathematics objective questions. And so the other day and then yesterday, we were able to get to question number 23. And so we'll continue quickly from question 24 to question 28 per what I have over here. So the question 24 says that we should find the minimum value of y is equal to. We've been asked to find the minimum value of y is equal to x squared plus 9x minus 17. And then to do this, we need to use the concept of completing the squares to get this particular one done. And so what we are going to do is to look out for the coefficient of x in this particular question. And then we are going to apply that particular concept, just like y is equal to ax squared plus bx plus c, where we find half of b and then we square that one, add to the right hand side because we are just looking at the right hand side. We add to that one and then subtract again. So that is what we are going to do over here. So we know the b from this concept is 9. And so we find half of 9. So it's going to be 9 over 2 and then we square it. Now we add to both sides and then we subtract from both sides. We add to both, we add and subtract from both sides, sorry. No, not both sides. We add and subtract from the right hand side because we want to focus on this side. So y then becomes x squared plus 9x plus 9 on 2 all squared minus 17 minus 9 on 2 all squared. So now from the reason for the finding half and adding the square to both sides or adding and subtracting from the right hand side is because we want to simplify this using this concept. And so we have x plus 9 and 2. When you expand this, you're supposed to get back this one. And then minus 17 minus 81 on 4. Now we work on this side. When we work on this side, the LCM is going to be 4, and then this is going to be 4 times 17. That should be around, so 4, 7, 28, 4, 1, 4, so minus 68 minus 81. #68 plus 81, 9, this should be 14, so 149. The minimum value occurs at this particular region, which is the minus part, when x plus 9 on 2 all squared is equal to 0. The minimum value occurs over here. So therefore, the minimum value negative 149.4. So this is where the minimum value is occurring. And so when we look at the possible options that were given from the beginning, we have 149 on 4, 49 on 4, minus 49 on 4, and then minus 149 on 4. And so minus 149 on 4 is the option to be chosen in this particular situation. Question 25 says that we've been given that 1 plus root of 3 all y is minus x root of 3 is equal to 5. We should find the slope of the line. And so we assume this is a line, and then we know the general formula. Yeah, the general formula for a line, a straight line, is given by y is equal to mx plus c. Others prefer to use y is equal to ax plus c, but I'm using y is equal to mx plus c, where my m is the gradient or slope. And then it will be better if I'm able to express this in terms of y is equal to mx plus c. And so all I did was to move my negative x root 3 to the other side so that it becomes a positive root x plus 5 because the 5 is already positive. And then this is the situation I have. Now I want to make y the subject. And so I have y is equal to root of 3 on 1 plus root of 3x, or x like this, and then plus 5 on 1 plus root of 3. And then this is the value for m. From comparison, we can see that this is the value for m. And then if this is the value for m, in mathematics, it's a haram or a taboo to leave your fraction with a z as the denominator. And so because of that, we have to rationalize this particular fraction. And then to rationalize this, we need the conjugate of the denominator. The conjugate has to do with changing the operation sign here from plus to minus or from minus to plus, depending on the question. And then use that one to multiply the numerator and denominator. And so I'm going to multiply my numerator by 1 minus root of 3 all over 1 plus root of 3, 1 minus root of 3. Over here, I apply the concept of difference of two squares. 1 times root 3, that should be root 3 minus 3 all over 1 squared minus root of 3 all squared. This gives me root 3 minus 3 on 1 minus 3, which is giving me root of 3 on minus 2 plus 3 on plus 3 on 2, sorry. And so therefore this is my slope. So therefore m is equal to 3 on 2 plus root of 3 on 2. So here is going to be minus, and so minus, yes. Let me just compare this with the options that we have and see which one best suits. So the first option that we have is minus 3 on 2 plus 1 on 2 root 3. Second one is minus 3 on 2 minus 1 on 2. Option A and B are out. Option 3 is 3 on 2 plus 1 on 2. That one is also out. The option D is 3 on 2 minus 1 on 2 root 3. So this is the option. Option D is this particular one. Now we go to question 26. And then with the question 26, I beg it is going to be a bit technical, but you have to understand what I'm trying to say. So I'm going to use examples to be able to see which of them will not make sense. So let's assume we have a universal set, which is 1, 2, 3, 4, 5, and then 6. And then let's assume we have P to be 1, 2, 3, and then Q is equal to 4, 5, and then 6. Using this concept, maybe you'll be able to understand what we are doing over here. So we start with the option D. Option D is that P union Q should be equal to the mu or the universal set. When we take P union Q, we likely get this. So that one makes sense. The second one is that P intersection Q, they don't have anything in common, and so that is also going to give us an empty set. So D and C are making sense. Let's come to the option B. Option B is that P intersection Q, which is already a noun set, and then P intersection Q all complement. What is it that we don't see here but we see in the universal set? It is the whole of the universal set, which is equal to the mu. And so we see that giving us mu is the same as P union Q from the option D. And so we see that option C and then option B are the same. Now let's come to the option A. It says that P complement. What is P complement? P complement is equal to Q. And at the same time, Q complement is also equal to P. That is what the question even said from the beginning, given that P is a complement of Q. Where P and Q are subsets of the universal set mu, which of the following is not true? So if P complement is equal to Q, and then Q complement is also equal to P, then this situation or the example here will make sense perfectly. Now let's proceed further. P complement, which is equal to Q, union q complement, which is also equal to p. Now, when we find a union of p or q union p, it should give us a universal set, which makes sense. But that will not give us p intersection q, which is also equal to a noun set. And so we can see clearly that the statement A is not true. And so we conclude by saying that from these examples that we have demonstrated, the statement A is not a true statement. All right, so that is it for the question 26. I don't know what to say again, but yes, that is it. Let's go to question number 27. Question 27 says that a particle is acted upon by the forces F1, which is 7.3 Newton. We have F2, which is also 3-1 Newton. And then finally F3 minus 2.5 Newton. Find the force required to keep the particle in equilibrium. So we have three forces which are acting on an object. We first of all need to find the resultant force. So finding the resultant force simply has to do with a combination of the three forces. When we combine all the three forces, that is what we call the resultant force. And so F1 plus F2 and then plus F3. F1 is 7.3, F2 3 minus 1, F3 minus 2, 5. 7 plus 3, 10, 10 minus 2, 8. Yeah, so 10 minus 2, 8. And then 3 plus 3 minus 1, that should be 2, 2 plus 7. So we have 8, 7 as the resultant vector or the resultant force. Now, the force which is needed to keep this particular object in equilibrium has to do with the negative of the resultant force. So it's just like the forces acting upon the body, let's say, are coming in this direction. So if they are coming in this direction, if I'm here, the forces are coming on me, I have to go back. So what are the forces that are needed to keep me in this position whilst these forces are acting on me? There should be another force from the back which will keep me in motion, or which will keep me in a stiff or equilibrium position. And so the forces acting on me from my front will need an equivalent force acting on me from my back so that I'll be in the same position. So this is coming this way, this also needs to come this way, so that the objects will be in position or will be in an equilibrium position whilst the two forces are acting. And so the negative of this particular force is what is needed. And so that is going to give us minus 8 minus 7. And then we can see that which is given as option B. So option B is minus 8 minus 7. Then finally, we look at question 28. Yeah, so finally, question 28 also is asking us to find the coefficients of x power 3, x power 4, and then y power 3 in the expansion of 2x minus y onto all power 7. I wouldn't want to quote any complicated formula. All I would want us to do is to use a Pascal's triangle, where we have any number raised to the power 0 has a term, power 2, 1, 1, 3, 1, 2, 1. So power 1 is this, power 2 is this, power 3 is 1, 3, 3, 1, power 4, 1, 4, 6, 4, 1, power 5, 1, 5, 10, 10, 5, 1, power 6, 1, 6, 15, 20, 15, 6, 1, power 7, 1, 7, 21, 35, 35, 21, 7, 1. So we are going to use 1, 7, and then there is an easier way, better. Because it's power 7, the first one is going to take, when we have the coefficient as 1, it is going to take 2x to the power 7. And then we need x to the power 4. So this is power 7, power 6, power 5, power 4. So we use 35 against 2 to the power x power 4, and then against minus y on 2 to the power 3. Anytime you are working, the two powers should give you the total power, which is power 7. And so from here, we have 35, 2 to the power 4, that is 16, x power 4, by against this is going to be minus y to the power 3. This is going to be on 8. 8 here 1, 8 to 16. 2 times 35, 70 x power 4 against minus y power 3. Minus times this, minus 70 x power 4 y power 3. And so this has been the answers from question 24 all the way to question 28. I'm looking forward to bringing you more as the days go by. Thank you so much for your time, and then I would be happy if you can subscribe to my YouTube channel and then follow on all social media accounts so that anytime we bring any educational content of this nature, you'll be able to get access to it. Thank you so much, and then have a nice day. Bye.